right? So just to recap, how would we do part A? Well, this is multiplication, right? So what we need to do is this. Multiply the terms by each other. So 4 multiplied by 3 would give you 12. And then we would have p squared multiplied by p to the 5th power. Right. Now we need to remember one rule here, right, from indices or powers. P has the same base, but the power is different. So we have to remember the rule where we add the powers when we multiply. So how would we work it out? It would be 12p to the power of 2 plus 5, because when we multiply powers and they have the same base, we add them. We add the powers 2 and 5. So your answer would have been 12p to the power of 7 for this problem. Now, I'm giving you guys 2 minutes to work out question number 2, and then I will proceed to work it out. Right? I want you guys to practice working the problems in as much as we want the solutions. So your 2 minutes begins now. So you guys can go ahead.
Excuse me, do we have to write the first question in our books?
Yes, you can write it down, but we'd have done that last week. The last time we had class, we stopped at this one. So I know we did this already. So we are on to this question, part 2. So you can write from part 2. Now, in case you get the answer wrong, you can write it on scrap first. So when I provide the solution, you can write my answer. Right? Or if you feel comfortable, write in pencil first. So go ahead. I will let you know when your time is up. Okay, guys. So by now you should be almost done or through the question. If you are not, don't panic. This is the point of the past paper session, right? I'm just giving you a timeline which you should have been done with the problem. So let's actually work this problem out from scratch. So we have 3x divided by 4y cubed, right? That's one part of the fraction divided by 21x squared over 20y squared. So I'm just going to stop share so we can see the video, which I'm going to write the answer on the whiteboard. So let's walk through this problem. So the first step would have been to make this problem a little bit easier for you to see was convert that division into multiplication. Now, you don't necessarily need to do that, but it makes the problem a little bit easier to work out. So we would have this. We change the division to multiplication. Now, if we do that, we need to reciprocate. Sorry, this is supposed to be 4. We need to reciprocate. So what reciprocate means you put the numerator where the denominator is and vice versa. So we will have 20y squared would come here, divided by 21x squared. So that would have been step 1, changing division to multiplication. Right, so this is algebra, and also some indices involved. Now, which number can we cross out if we want to use that? Let's look at it 3. 3 can go into itself 1 time. 3 can go into 21 7 times. So let's get rid of that term first. What would we be left with? We'd be left with, okay, let's see what can be done as well on the 4 and the 20. So 4 can go into itself 1 time. 4 can go into 20 5 times. So I'll just write in this as steps in your working, so you can see what's going on. Right, so now let's rewrite this into something we can follow. So we would have simply x here divided by y cubed. Remember, 4 and the 5 could cancel out, the 3 and the 21 could cancel out. Multiplied, instead of 20, we can write 5y squared. And instead of 21, we write 7x squared. So are we done here yet? No, because the question asks us to simplify it as much as possible before we do that. So if we need to simplify this, we need to remember our rules of indices, which is a common theme that you can see in a lot of your algebra problems. The rules of algebra indices, there are 2 important ones that you need to know. So one would be if they have the same power and if you multiply. So I'll just write it down so we can be familiar with them. So what I mean by that is simply this. So for example, if you had x squared and you multiply by x cubed, the answer would have been x to the power of 2 plus 3 to give you 5, as we had in part 1. Now the other rule states that if you divide now, so I'll write the other rule on the side. So the other rule of indices we need to know is that you have this now. So for example, if you had x cubed over, what would you do? This would be a to the power of n minus m, which you can write x to the power of 3 minus 2, which would give you 1. So when you divide, you simply subtract, right? And when you multiply powers that are the same base, so it must be the same base, right? So for example, this must be an x. Now you could have a 2x, right? Because 2 is multiple. So when you multiply 2, you would simply get the powers is the thing you have to pay attention to. So let's keep those two rules in mind before we proceed. So in proceeding, let's work it out. Now let's write what this x over y cubed multiplied by 5y squared over 7x squared will become. So we can simply get this. X, so I'll put the 5 on the outside, you can put the numbers on the outside. So that's when we work out the top part, the numerator, the denominator. We can also put the numbers on the outside, 7, and we'd be left with, now let's try to make it look like the same thing. So we put the x's first, and then the y's. Right, now are we done here yet? No, we aren't, right? Because we can simplify this even further, believe it or not. Right, now x over x squared is using this rule, actually both of them, right? It's like saying x to the power of 1. Remember, this is when the power isn't given, it's like 1. So it's saying x to the power of 1, and we already have x squared. So how can we write this? We can write this as 5 over 7 but we'd write x here, right? We'd get x to the power minus 1, but think about it like this as well. We have an x here and we have x squared. What is x squared? X squared is simply x by x. So because we have an x on the numerator, we can cancel 1 from the numerator, and we left with 1 in the denominator. In a similar manner, that would happen in y's. So in the case of the y's, the same idea would happen. What is y cubed? Y cubed is like saying y by y by y. Y squared is like saying y by y. So we can cancel out these terms together from the numerator and denominator, and that would give us simply y in the denominator. So this would be the solution for your problem, right? But I explained all the steps involved in working it out, right? So before we proceed to another question, let me know if you got this or if you were confused. Good job, guys. So let's proceed to another question, which is a section 2 question again. So let's look at part B, where they ask us to solve the equation. So this is something you have one thing to do before you solve it, right? So the hint I'm giving you for part B is to cross multiply. That's all I'm saying. So take 2 minutes to work the problem out, and then I will provide the solution for you guys. So we can start now. Okay, guys. So by now, you should be able to have solved the problem given the time constraint in the exam, right? But we're not in an exam, we're just practicing as though we are in one. So let's see the solution for this problem, right? So the reason I give you guys time is to actually work it out. Now let's see if you can get the answer I got. So we have to solve this. 3 over 7x minus 1 plus 1 over x equals to 0. So one of the first steps you need to do is find the LCM. Now, this is algebra, right? Usually when you have to find the LCM, let's say this was 5, and let's say this was 2, you'd have simply multiplied the 2 here, right? So this would have been 5 by 2, but you would have to multiply 3 by 2. So this is what you would do when you're solving for this one. So the LCM would be 7x minus 1 by x, right? Throughout. That's the denominator we would have now. Now what we have to do here, we have to multiply 3 by x. And that would have been the first step. Now, to get back this 1 over x, we'd have to multiply 1 by this part, which would be 7x minus 1. Keep in mind, it's all equal to 0. So that would have been the first step, find the LCM. The second step would be to simplify as much as we could. So let's try to simplify this. So don't expand anything as yet, and you could see why I would do that, right? So 3x plus 1 by 7x would simply be 7x, and we would have minus 1 here, 1 by minus 1. The denominator would be x minus 1 by x equal to 0. Right. So what can we get here when we simplify further? We can get 10x minus 1 over 7x minus 1 by x would be 0 when we simplify. Remember, this is algebra. It's like saying 3 apples plus 7 apples. That would give you 10 apples. So that's an easy way to remember it. 3 biscuits plus 7 biscuits equals 10 biscuits, right? So don't let algebra confuse you. 3 markers plus 7 markers equals 10 markers. Once it's the same thing, you can add them, you can group terms. So now let's work out this. Right, now when you're given something over this equals 0, we know for sure, once you're given that term, it implies that 10x minus 1 would be 0. Now, why is that the case? Well, because if this term is 0 here, you would get an undefined, you would get an error in your calculator or infinity. So this term cannot be 0, right? For sure. So you know x cannot be 0. And if you multiply both sides by this, anyhow you take it, you would get 0 multiplied by this whole expression, right? And you would simply get 10x minus 1 would be 0, which is this part here. If you were to multiply this across, it would be 0 by this whole thing, which would be 0. Remember, 0 multiplied by any term is 0. We'd be left with 10x minus 1 equal to 0. And we solve using our algebraic properties that we would have talked about in one of the classes. So minus 1, what do we do to both sides of the equation when we are solving? We get 10x, we would add 1 to both sides, so this would become 1. Yes, I know some people say carry over the minus 1 and it becomes plus, but in essence, what you're doing is adding 1 here and adding 1 here.
Excuse me, sir. I'm not seeing what you're doing because the thing blocking it.
What blocking it? The question itself?
No, the screen in the corner.
Okay, so what I'm writing is, so what do you have?
Blocking it.
So what do you have until what can you see up to? You see up to 10x minus 1 over 7x minus 1 by x.
I'm not seeing anything, sir.
All right, let me try it again. Right, so that would be the question. I'm going to stop sharing the question so you can only see the video now. So you're supposed to be able to see it now.
So you could go back how you was before?
On the question?
Yeah, go back on the question.
Right, so this is the question. Right, we're looking at part B. Right, but what I was sharing was the solution, the write-up.
Yes, that one, but something was in the corner, something black in the corner was blocking it.
So let me try now. So we'll be able to see it. So what to do, go and click on the right-hand corner if you're not seeing it, and you should see one of the videos come up. That would be this.
Yes, I've seen it.
Okay, great. So where we was at was this part here when we're solving. So what I'm saying is this. So the first thing we do was find the LCM. When you find the LCM, normally if this was a 5 and let's say this was a 2, you would multiply 5 by 2 to give you 10. Right? And what you would do now, after you multiply the 5 and the 2 to give you 10, you would have to multiply this by x, right? This one by this, and we have to multiply this by that. It's like you cross multiply. And then you would proceed to simplify. So at this point here, where you have a numerator and denominator. Now, when you reach this point, you would have a 0 here. You multiply this term by 0, you would get 0 as well. So you would get to this point. Now, when you reach to that point, it's simply algebra. Normally, you would hear some people say carry over the 1, the negative 1, and to become plus 1. But what you're really doing is adding 1 to both sides. So when you add 1 to both sides, this will become 10x plus 1. Now, how would I solve for x here now? So 10x equals 1. What does this really say? It's saying like 10 multiplied by x. So we need to divide by x by 10 in this side, right? Because the opposite of multiplication is division. And that is how we have gotten the solution for that one. Right? So before we go into another question, let me make sure you guys are following it. So this is a lot of algebra and solving for x and so on. Right? But those will be the steps in detail, how to proceed. Sorry, doing the question. Wonderful, guys. So let's go to another question. So I'll stop sharing the video and share the question again. Right, so we did all these. Right, so let's do a little different question now. Right, now this question looking very strange and looking complicated. But it's actually not. Right, so this is using either Pythagoras Theorem or the trigonometric ratios. So that's the biggest hint I'm giving you guys. Right, so it's a right angle triangle, so we either using Pythagoras Theorem or
Excuse me, sir, do I have to draw it?
You can take a screenshot of the question if you like. But
Okay.
drawing it sometimes helps you. Right, so go ahead, take 2 minutes for the first part. Then I'll explain it. So start now. Right, so for those of you who in the Form 1 to 3 class, we'd have done Pythagoras Theorem, we'd have done the trigonometric ratios. So this one is an exam type question to that. So let's see how we do it. Okay, guys, so by now we should be finished with part A if it was an exam setting. Now let's look at this. Now you only see an A, B, C, the angle theta, which is here. Theta is here, that means the angles inside. But what type of triangle is this? It's a right angle triangle. Right? If you look at the information in the question given, you would see it. Right angle triangle. So this is the hint I give you guys, where you can either use Pythagoras' theorem or the trigonometric ratios, sine, cosine, and tangent, or SOHCAHTOA as we know it. So A asks you to express C in terms of A and B. Now, what is C? C has to do with length, right? So because it's the length we're dealing with, what we're going to use is Pythagoras' theorem. Remember, the property for using Pythagoras' theorem was that if it's a right angle triangle, two of the lengths are given and we need to find one. So that's the case in question A. So for part A, we need to use Pythagoras' theorem. So let's go into the question. So I'm going to share this so we can see. Now, this is not the best drawing of me, but I want to replicate the triangle there. So we still have A, B, and C, right? Now, first, let's state Pythagoras' theorem. Now, I would state Pythagoras' theorem, and it's a good practice to state the theorems you use, especially in a math exam. So it could be for CXC math, it could be if you're doing any other levels of math further. It gives the person marking your paper a clear indication that you know what you was doing. So the first thing was to use Pythagoras' theorem. Right? You don't even have to spell out Pythagoras. You can leave it like this. We know what you mean by that. Now, what does Pythagoras' theorem state? It states the hypotenuse squared would be equal to the sum of the squares of the other two sides, right? So this is just the general form of the Pythagoras' theorem, right? So that would have been the first step. Now, what is the hypotenuse? The hypotenuse is the side that's opposite the right angle. So this is the right angle. The hypotenuse would be C. So now we need to input into the formula. So the h squared would simply be c squared. That would be equal to a squared or b squared. Now, a squared or b squared does not matter which side you use, right? Because these are the other two sides of the triangle. That's not the hypotenuse. So because it's not the hypotenuse, we could simply read it as it is. So it would be a squared plus b squared. B squared will remain as b squared, luckily in this case. Now we ask to express c in terms of a and c. This is c squared. So what we need to do is make c the subject of the formula. So c would have been the square root of a squared plus b squared. That would have been the length c here given. Right? Yes, when you carry over or when you take the square root, you're usually supposed to take plus or minus. Right? But length is always positive in these real world situations. So it would have just been the square root of a squared plus b squared. So let me recap. Why did we use Pythagoras' theorem? We needed to find the length of c. So Pythagoras' theorem can be used in a right angle triangle when you're given two lengths and you need to find for one. That is why we use it. It's a right angle triangle. That's the two main features where we could use Pythagoras' theorem. What does it state? The hypotenuse squared is the sum of the other two sides squared. So the hypotenuse would be c because it's the side opposite the right angle, which is why we have c squared here. A squared and b squared could be any one of these two sides. So we add them up, and that is what we would get. Right, so this is how we would solve that part of the problem. So let me just relaunch the poll. Let me know if you're confused how I arrived at my solution. Right, I'm taking my time to explain the problem. Remember, it's a good practice for you to attempt the problem first. Don't just wait for me to give you the answer. This is actual paper 2 questions on the CSEC math syllabus. Right, guys, so we have time to do approximately 1 or 2 questions. So let's see how far we can get through. So let's try part B now.
Excuse me, sir.
Mhm.
I didn't get the example it was given because my tablet did cut me off. I didn't know what to do for the first part.
Okay, no problem. So this is the solution here that you have gotten, right? So you see this screen now, right?
Yes, sir.
Okay, so we don't have to use Pythagoras' theorem. Why? Because it's a right angle triangle, and we need to find the length of this side. That is why we use it. So Pythagoras' theorem states the hypotenuse squared is the sum of the square of the other two sides, right? That's the formula. What is the hypotenuse? It would have been C, right? The side opposite the right angle is the hypotenuse. So this is why we have C squared here is equal to A squared plus B squared. So A squared is just this, B squared is just that one is squared. What you need to do now is make C the subject of the formula. So C squared, you need to write it as C. So if we have to go from square to this, we have to take the square root. And this is how we would have gotten A plus A squared plus B squared. Right? So that would have been the first part of the problem. Right? Following now?
Yes, sir.
Okay, great. So you can take a screenshot of this, and I want to move on to the next part of the problem, which is a little more complicated. Right. So I'm proceeding to move to the next part of the problem.
Yes, sir.
Turn off my video for a while, so let's go here. Right, so now part B is where things can become a little confusing to you, right? But what you need to do is remember that we can only use either two things, Pythagoras' theorems or the trigonometric ratios. So what does the trigonometric ratio state? Well, we use an acronym to help you remember this. So, ka, so, right? So remember, so just for general knowledge, sine theta would be equal to opposite side over hypotenuse. That's one. And cosine would be equal to adjacent side over hypotenuse. Right? So that would have been the knowledge needed to solve that problem for part B. Now, the reason why I'm working this out, because it could have been a little confusing for you guys. So let me make sure you get it. So when they say write in terms of A, B, and C, expression for sine theta plus cosine theta, we needed to find what sine theta is, we needed to find what cosine theta is, and then add them up. So this is how we would do this. So I'm going to go to the video so you can screenshot the question before we proceed. Right. So we need to find, this is what we need to find. Right, so let's consider sine of theta. Now remember, theta is this angle here. The hypotenuse is always fixed, it's opposite the right angle triangle. So let's consider what sine of theta is. So sine of theta, or so, remember the acronym, would be opposite over hypotenuse. Right, so what is hypotenuse? We know hypotenuse would be C in this case.
Excuse me, sir.
Mm-hmm.
With the word next to SIN, the word next add the word of
Cosine, cos, C-O-S theta. Yes, cos, cosine, but the abbreviation is cos, C-O-S.
Okay, sir.
This is what the question asks for, sine plus cosine. Right, so what we need to do is first find sine of theta. Now remember, from a trigonometric ratios, sine theta is opposite over hypotenuse. We know the hypotenuse is C. We know that part already. So I could write that. H, the hypotenuse, would be C. Now, how do we find the opposite side? Now, let's consider the angle here. This is the angle. Which side would be opposite the angle? A would be opposite the angle, right? This is the angle. Opposite side would be A. Let me write it better. So we'd have sine theta would be equals to A over C. So that would be this part. Now we also need to work out cosine of theta. So how do we work out cosine of theta? What is cosine of theta? Cosine of theta would be adjacent over hypotenuse, or if you remember, ka. So ka to. So ka adjacent over hypotenuse. Now what would be the adjacent side? Well, we already established the opposite side was here. So the adjacent side would be B, right? Remember, opposite. This would be the hypotenuse because it's opposite the right angle, and here would be the adjacent. So the adjacent side would have been B, right? B is the side closest to the angle. The hypotenuse would remain fixed, right? Because it's C, and we'd have gotten that. Now the question says sine of theta plus cosine of theta. So what is sine of theta in this case? Sine of theta would simply be what we found here. So it would be A over C. Cosine of theta would be B over C. And that would have been your solution for this problem, right? So the first thing, it might have looked confusing because you see an A, B, and C. But just think about the problem in terms of what it is. It's a right angle triangle. Two things you can do with a right angle triangle: Pythagoras Theorem and the trigonometric ratios. So Pythagoras Theorem involves the length. So we've done that in part E. For this part, A part 2, we need to find sine theta plus cosine theta and write that in terms of A, B, and C. So to do that, we simply need to find sine of theta, find cosine of theta, and then add them up. Sine would be opposite over hypotenuse. The hypotenuse would be the side that's opposite the right angle, which would be C. The opposite side to the angle would be A. So if you check the angle and you look opposite, it would be A. And here would be the adjacent side. So sine of the adjacent over hypotenuse would be simply be, sine would be opposite over hypotenuse, which would be the A over C. Cosine would be adjacent over hypotenuse. So C is the hypotenuse, that remains as is. How did we get B? Well, if this is the angle and this is the opposite side, this would be the adjacent. And that is how we would solve this problem. So before we go, guys, let me just make sure you guys understood this problem. It was an application of the trigonometric ratios. So you can screenshot the solution. Let me know if you are confused or not before we end this tutorial. Right, so all these problems was taken from literal exam papers, right? So you're supposed to be getting there towards this level. So guys, we have come to the end of this tutorial. It was a pleasure serving you today. Please take a minute to fill out the quality control questions that would appear at the end of this meeting. Please let us know what you'd like us to do differently and how we can improve to better serve you. Thank you for choosing BetterGradesFast.com. Do have a blessed day, guys. Take care until the next past paper session, which will be next week, Tuesday. Goodbye.
Bye, sir.